So good afternoon, everyone, and welcome to today's lecture. We were dealing with angular and linear quantities in the last class, and we had seen the relations between them. Do we remember the relations? The first relation that we saw was between the distance and the angular displacement. Distance L is angular displacement multiplied by r. Then we saw the relation between tangential velocity and angular velocity. Tangential velocity is omega cross r, simply omega multiplied by r in magnitude. Then we saw between linear and angular acceleration. Actually, we saw between tangential and angular acceleration alpha cross r. Do we remember this?
Yes, sir.
Then we saw what happens. What does tangential acceleration do? Tangential acceleration changes the magnitude of velocity, or simply it changes the speed. And then we saw the normal or the centripetal acceleration that changes the direction of velocity. Yes or no? And in the end, we saw that the acceleration that we call as acceleration is actually consisting of two components. One is the tangential component and the other one is the normal component. Yes or no? So in general, if I talk in general, let us write things in general. And if I draw the diagram of general motion, let us say a particle is moving on a track like this. We are talking about general motion. And at some point, he is here. Okay. Now at that point, when he is here, his velocity is always tangential to the path. Did I tell you that? Yes or no? So this is the direction of his velocity. We can call it tangential velocity. Now we can have an acceleration which can go in any direction. His acceleration may be going like this. Acceleration has got nothing to do with in which direction your velocity is. So your acceleration may be in this direction. We understand this, everyone? Now this acceleration can be broken into two components. What are the two components? One component is tangential acceleration, which may lie in the same direction as velocity or in the opposite direction. The other one is your normal or radial acceleration. Do we understand this? This normal or radial acceleration will be pointing towards what? This normal or radial acceleration will be pointing towards what?
Center of a circle, sir.
Yes, every arc is a part of a circle. So this will point towards the center of that. It may be a circular path, it may not be a circular path. So in general motion, it is known as center of curvature. What it is known as? It is known as the center of curvature. And then we have this distance of the particle from the center of curvature. What will I call this? What will I call this? What will I call this? O is the center of curvature. Particle is somewhere there. What will be the distance of particle from the center of curvature be known as? What should I call this?
Sir, radius.
Radius of what? This is R. This R is known as radius of curvature. So for any general motion, we can write it like this. Center of curvature and radius of curvature. For any general motion, you may have normal acceleration. This acceleration will change what? It will change the direction of velocity. Velocity means Vt. It will have a tangential component. What will this do? It will change the magnitude of velocity. And then you have the summation as this. What will this do? Change magnitude and or direction of velocity. So it can change either magnitude if it is only tangential. It can change only direction if it is only normal. Or if it is a combination of both, it can change both. Do you understand this?
Yes, sir.
This is how we define general motion. So I have given you that concept of general motion as well. Give you 2 minutes to note this down. Are we ready to solve some questions? Yes or no?
Sir, wait, sir.
Okay. Let me know once you're done.
Sir.
Shall we start with the question?
Yes, sir.
Sir.
Okay, so this is the first question that we are dealing with. The question is pretty simple. The speed of a particle traveling in a circle of radius 20 centimeters increases uniformly from 6 meter per second to 8 meter per second in 4 seconds. So to find the angular acceleration. Remember simple things. You just have to remember the name of the terms and what they are doing. Once you understand them, things are going to be pretty simple after that. I'll give you 2 minutes to note this down and solve it and give me the answer.
Zero 0.1 meter per second square, sir.
Angular acceleration, can it be in meter per second square? What is the SI unit of angular acceleration? The SI unit of angular acceleration is radians per second square. How can you get the answer in meter per second square? Shall I do it?
0.1. 0.1 radians per second. 0.1 radians per second square, sir.
0.1 radians per second square is not correct. Yes? Boys class, do we have any answer? Yes?
2.5.
4.5? No, no, no. 2.5 radians per second square. Is that what you're saying?
Yes, sir.
That is correct, sir. 2.5 radians per second square is correct. How are you supposed to do this? There are two different ways in which you can do this. First of all, let us try to understand what all things are given here. Radius of the circle. So R is given. The only thing here is R is given in centimeters and not in meters. So that is what you have to remember. The speed of the particle, magnitude of velocity, changes from 6 to 8. So this is your initial speed. Wrong color. This is your initial speed. You can call it V1. This is your final speed. You can call it V2. 4 seconds. That is the time. So speed of the particle is changing. Who changes speed of the particle? Tell me. Who changes the speed of the particle?
Acceleration.
What we have done here, please remember what we had done in the previous class. Who changes the speed of the particle? Again, I ask the question. Okay, I'll give you 5 minutes. Please go through what we had done in the previous class. It looks like we have not understood anything. So I'll give you 5 minutes. Please go through your previous class. Please go through your notes, and then we will solve the question. Okay. No point of telling you the answer and solving it once you don't understand it, right? So I'll give you 5 minutes. Go through this. It looks like you have not seen what we have done.
Sir, tangential acceleration.
Tangential acceleration changes the speed. So from there you can find out the value of tangential acceleration. How can you find out the value of tangential acceleration? Tangential acceleration will be the final speed 8 minus initial speed 6 divided by time 4. So you will get the tangential acceleration as 0.5 meter per second square. That is your tangential acceleration. Once you know the value of tangential acceleration, you also know tangential acceleration can be written as alpha multiplied by r. From there, you can find out the value of alpha. Tangential acceleration divided by r. Tangential acceleration is 0.5 divided by r is 20. R is not 20, r is 20 centimeters. So to divide it by 100, so basically it gets multiplied by 100. And you have your answer. The acceleration, angular acceleration is 2.5 radians per second square. Do we understand this?
Yes, sir.
This was one way of doing it. The other way of doing it was, this is V1 is given. V1 can be written as omega 1 into R. So from there you can find the value of omega 1, V1 by R. Then you can find the value of omega 2, which is V2 by R. We know the final angular velocity, we know the initial angular velocity. Then you can calculate alpha omega 2 minus omega 1 by t. Even if you do it in this way number 2, you will end up with the same answer. It will be 2.5 radians per second square. Do we understand this? I'll give you 2 minutes to note this down. If you have any doubts, please ask. Once you are done, please let me know so that I can move on with the next question.
Done, sir.
Done, sir, everyone, boys?
Hi, sir.
Then comes this question. A particle is moving in a circle of radius 10 centimeters with uniform speed. What type of motion is this then? It is moving in a circle of uniform motion, in a circle of radius 10 centimeters with uniform speed. What do we call this type of motion? This
Uniform circular motion, sir.
uniform circular motion. In uniform circular motion, your omega angular velocity is constant. What about your other thing? I've also told you, when omega is constant, then what is zero? What is zero then?
Acceleration is equals to 0, sir.
Not acceleration. Acceleration is not zero. Acceleration is not 0. What is 0?
Tangential acceleration is 0, sir.
Tangential acceleration is 0. That means your alpha is 0. Because if the acceleration is 0, then what they're asking? Find the magnitude of its acceleration. They are asking you to find out the value of A. You have 2 minutes to solve this. Yes, do we have an answer?
Zero point 0.62 meter per second square, sir.
0.62 meter per second square. How did you get it? Okay. Uniform speed, this is a uniform circular motion. It completes the uniform circular motion in 4 seconds. What is this 4 seconds actually equal to? What is this 4 seconds actually equal to? This is equal to its
Time.
everything that I've done in the past 3 days. It seems that this has gone down the drain. No point of
Revolution.
yes, beta.
Revolution.
What is 4 seconds that is given there? That is the time period for a uniform circular motion. I hope you remember this time period of uniform circular motion, 2 pi by omega. It is sad that I don't know what you are doing. This 4 seconds is the time taken to complete one revolution. You cannot forget time period, beta. Cannot forget time period. It is a cardinal sin. You can probably murder a person and get away with it. But if you forget time period, you cannot get away in an IIT. No way. Cannot forget what is time period. Cannot forget what is time period. You just cannot forget what is time period. So time period T is given as 4 seconds and that is equal to 2 pi by omega, where omega is the angular velocity. So from here I can get omega as 2 pi by 4. My omega becomes pi by 2 radians per second square. I have to find out the magnitude of its acceleration. I will start with finding out the normal acceleration or centripetal acceleration. What is the value of its normal or centripetal acceleration? What is the value of its normal or centripetal acceleration? No one knows it. Yes, beta? Can't hear it. Normal or centripetal acceleration is omega square multiplied by r, where r is the radius of the circle. So omega square will be pi square by 4 multiplied by radius of the circle is 10 centimeters. So I convert it into meters. So pi square by 40 becomes its normal acceleration. Normal acceleration. If we talk about this tangential acceleration, the tangential acceleration is 0. Total acceleration is under root of an square plus at square. It does not have any tangential acceleration, so this goes away. So the total acceleration is pi square by 40 meter per second square. And that is the answer that I was looking at. I don't know what you have got, but this is the correct answer. How many of you got this? I don't see. I see a single hand at the back, 2 or 3 hands at the back bench. Apart from that, I don't see anyone getting this answer. Now tell me what in this question you did not understand. Tell me that. Which part of this question was unclear? If it is unclear, that means we have not gone through. How many of you have studied before coming to the class today? How many have you gone through the notes? 1, 2, 3, 4 girls have gone through the notes. You don't remember omega? You don't remember time period? You don't remember UCM? You don't remember tangential acceleration? What is there new in this question? I don't understand. Old question. ATN. The only thing is we have not done a question with ATN. That is the only new thing. But you will have to do it someday or the other. Today was the day that we had to do it. But I feel a bit disappointed. I have high hopes from you, but it looks like my hope is going down the drain. Chalo then, I will move on to some other questions. Seems like you are not ready for these questions. So I will change the question and move on to other questions. Have you noted this down, everyone? Remember, if you are always noting down questions from the whiteboard, it is not going to help your cause. No one in this universe can clear JEE by noting down questions from the whiteboard. The only way you are going to clear JEE is by doing questions by your own hands. I hope you understand it. And I hope that you will try better in the next question. This is the next question. A particle moves in a circle of radius 20 centimeters with a linear speed of 10 meters per second. What is the angular velocity? I hope you can solve this for me.
Fifty radian per second square.
50.
Rad per second.
So the answer is
A. Option
option A. How are we supposed to do this? Omega, they are asking speed divided by time. Speed is 10. Speed divided by r. This is 20 centimeters. You convert it into meters and you get 50 rads per sec. That is the answer for this one. I hope we have got this one. Yes or no? Okay, chalo. Now I think we have gathered some speed. Let's see how you do with this one. Question number 2 coming on your screens now. A particle is moving in a circular path with velocity varying as time. Velocity varying with time as 0.5 t square plus 2t. If 2 centimeter is the radius of the circular path, what is the angular acceleration? Let's first do the first part. I can also add, chalo, find out the angular acceleration first. Let's see.
Option C, sir.
Yes.
Option C.
Option C is absolutely correct. Well done. I'll give other students a chance as well. How do you get this? Well, first of all, you must understand that here the velocity is varying with time in magnitude. The speed of the particle is changing. Do we understand this? Yes or no? If I find the derivative of this speed, dv by dt, if I find the derivative of this speed, I will get tangential acceleration. Do we understand this? So we find the derivative of this speed. We get tangential acceleration as 3t plus 2. This is your tangential acceleration. From tangential acceleration, which is alpha multiplied by r, I can find out the angular acceleration. So it will be 3t plus 2 divided by r. I put the value 3 into t is 2 plus 2 divided by r is 2 centimeters. So 2 converted into meters, 2 by 100. And here we have our answer. And the answer is 400 rad per second square. Do we understand this? Yes or no? Now I can ask one more question here. You have already calculated the tangential acceleration at 2 seconds. What is the tangential acceleration at 2 seconds? You just put the value of 2 time as 2 in the first equation. So tangential acceleration at 2 seconds would be 3 into 2, 6. 6 plus 2, 8 meter per second square. Yes or no? Can you find out the normal acceleration at 2 seconds? Can you find out the value of normal acceleration at 2 seconds? Yes. Can you find the normal acceleration at 2 seconds?
Radian per second square, sir.
How will you do it? To just find the normal acceleration, you can do it this way. You can Find it from V square by R. Yes or no? You find the value of V at 2 seconds. So V at 2 seconds will be 1.5 into 4 plus 8. 4 into, sorry, not 8. 2 into 2 is 4. So 1.5 into 4 plus 4 square divided by radius is 2 multiplied by 100. Do we understand this? Everyone? This is how you can always find your normal acceleration V square by R or omega square multiplied by R. 1.5 into 4 is 6. 6 plus 4 is 10. 10 square is 100. 100 into 100 divided by 2, I think you will get 50, 100. Yes or no, my dear friends? Now the third question and the last question would be find out the acceleration of this particle at 2 seconds. Find out the acceleration of the particle at 2 seconds. Can you do that?
Five thousand eight, sir.
So how much?
5008.
So to find out the total acceleration, you have to find the under root of 80 square plus an square. 80 is 400. So 400 square plus 5,000 square. Do we understand this? Anyone has doubt, please come up and ask me. This is the time when you can ask me any doubt. I'll give you 2 minutes to solve this. And then I'll give you the question that has come in JEE many times. Actually came in one of the IIT-JEEs. Then it has been repeated in many JEE main exams. Are we ready for this? Give you 2 minutes to go through the entire question. Everyone has noted this down? Shall I give you the question then?
Yes, sir.
Best of lucks. And if you can give me the answer to both the parts, that means you have understood this concept of linear and angular quantities. And I can stay at peace. Give you 2 minutes to solve this. Anyone with anything that looks like an answer? Shall I solve it for you?
4 random per second square, sir.
4
Random per second square.
random? What is random? What is random? Random is random number.
And per second square.
4 tangential acceleration is in meter per second.
Radians per second square.
Tangential acceleration cannot be in radians per second square, bacha. Only angular quantities are in radians. Angular acceleration is in radians per second square. Angular velocity is in radians per second. Tangential velocity cannot be in radians per second. Tangential acceleration cannot be in radians per second. Please understand this. Do we understand this? Okay.
Yes, sir.
Yes, sir. Chalo. So let us see at what all things are given to us. The radius is given as 20 centimeters. The speed or the magnitude of velocity is given as 40. Everything is in centimeter per second, so we can also find the answer in centimeter per second square. We have to find out the tangential acceleration at 4 seconds. How do you, or at 1 second? How do you find out the value of this tangential acceleration? Tangential acceleration AT is the derivative of speed. And what is given is magnitude of velocity. So basically it is given as speed. Yes or no? We find the derivative of this thing and it is coming as 4. It is constant. Whether you find it at 1 second, whether you find it at 2 seconds, whether you find it at 4 seconds, it is same. And your first answer is tangential acceleration is 4 centimeters per second, not radians per second. Please don't say. Then comes the second part. You have to find the total acceleration. Anyone able to do this? Or only we have found out one part, said, okay, one part is done, we are done, let's go and party. Today is Saturday night, so we'll party. Huh? Anyone got the answer for this one? No one got the answer. Boys, girls, wake up, wake up. How do you get the value of normal acceleration? Normal acceleration is V tangential square or V square by R. Do we understand this, or this has gone above our heads going saying bye bye? So it will be 4t whole square divided by R. So that is 16t square by r. You put the values, you get the answer. You have to find it at 1 second. So normal acceleration at 1 second. To put the value of time as 1 second. So it will be 16 divided by r. R is 2 centimeter. Let us keep it in centimeter only. So, oops. The answer here would be 16 by 2. 8 centimeter per second. That is your normal acceleration. You have got the value of tangential acceleration. You have got the value of normal acceleration, but that was not asked. What was asked to you was the value of total acceleration or acceleration. When I say acceleration, it means acceleration. When I say normal acceleration, I mean this acceleration which is trying to change the direction of velocity. When I say tangential acceleration, it is that acceleration which is trying to change the magnitude of velocity. When I say acceleration, that is the total acceleration. What is the value of total acceleration then? Oops, wrong color.
4√5, sir.
4√5, sir, but I am not very happy, sir. You should have done this question, sir, with your own hands, sir, without my help, sir. So it will be under root of 80. Oh, sorry, 80 is not 8. 80 is 4. 4 square plus 8 square. And the answer is 4√5. And the unit is not radians per second square. It is centimeter per sec square. Do we understand this? Yes or no? I need to have raise hands from everyone in the class. Boys are sleeping. With this, congratulations. We have come to an end of finally your motion in 2D. We have done everything that was possible in this universe. Maybe one or two things are left, but we will do them at a later stage. They are not required right now. So from the next class, we will be jumping on to the next chapter. And the next chapter is known as dynamics. We'll welcome force in the next chapter. Take care. Have a nice day. God bless you all.
Yeah, okay, sir. Bye.
Thank you, sir.
Topic for tomorrow's test is everything that we have done till now. I've sent the topic on that Telegram group of yours.